Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over the chain rule, more specifically its use with the power rule. So here I've got it kind of laid out, um, where f of x is some function g of x to the nth power. If we want to take the derivative of something like that, it'll be n times g of x to the n minus 1 power. This should look kind of familiar, because this is actually just the power rule. Times the derivative of that inside function g of x. Now I know this kind of looks complicated, but once we get going it won't be that bad. So here in example 1, we've got f of x is equal to 2 times x plus 5 to the third power. So we could distribute that out and get that huge function and take the derivative of that, but that's going to be a lot more work than it's worth. So if we break it into this chain rule, we'll have this function on the inside, 2x plus 5. This is really our g of x for the rule. Because the inside here isn't just an x, we can take that out and make that g of x and use the chain rule with it. So now we're really dealing with this g of x to the third power, which if we follow the rule, this will end up giving us 3 times g of x to the second power, because it's 3 minus 1 power, times the derivative of g of x. So from here, all we really need to do is find what the derivative of g of x is, and then we can plug everything back in and get our final answer. So the derivative of g of x will just be the derivative of 2x plus 5, which, remember, the derivative of 2x is just 2, and the derivative of this positive 5 is 0, so our derivative is just that 2. So now we can plug back in what we know. So we've got 3 times 2x plus 5, that's a 5, to the second power, times just 2 for that g prime of x. Now I'm going to simplify that just to 6 times 2x plus 5 squared. And this is where I would leave this answer. It's really down to what the question is asking for you to simplify it to, but for me this is kind of good enough. So moving to example 2, it'll be the same kind of thing, where we've got a function on the inside taken to the 7th power. So we'll just take this function from the inside and we'll make that our g of x for this function. So g of x is equal to 10x squared minus 5x plus 100. And again, you could actually take this to the 7th power and distribute it all out, but that's not going to be worth it for any of us. So just like the last problem, we'll just knock this g prime x out. So the derivative of 10x squared is just going to go to 20x, minus the derivative of 5x, which is just 5, and the derivative of 100 is 0, so that's where we're leaving it. So now we'll follow this rule. So our n in this case is 7, so we'll have 7 times g of x to the 6th power times g prime of x. And now we can take what we know and put it back in. So we'll have 7 times 10x squared minus 5x plus 100 to the 6th power times the derivative of g of x, the 20x minus 5. And again, I'm just going to leave it like this, because that's not really worth our time to distribute all that out. So overall, the chain rule, at least when it comes to the power rule, is mostly the same. Just we're going to take the derivative of the stuff on the inside and multiply it to the power rule that we have. And that's about it. Thank you for watching.